Okay, so here's a small point that we need about path components and open sets. Okay, suppose we've got an open subset of Rn, and let let V contained in U be a path component. So I want to claim that V is also open. And so the proof will so suppose that A is in V, then A is certainly in U, and U is open. So there exists some epsilon greater than 0 with the open ball around A of radius epsilon being contained within U. Okay, so now suppose B lies in this open ball. Then if we look at the line segment between A and B, so we just take the distance between this and A. Of course, that's just going to be T times the norm of B minus A. So that's still going to be less than epsilon. So this is in this open ball, which is contained in U. So it means that A is connected to B. By a path lying in U. So that means that the component of B is the same as the component of A. So in particular, B, so it's in the component of A, which is just V. Therefore, in particular, B lies in V. Okay, so that proves that the open ball, positive radius epsilon around A, is actually contained in V. So, and that's what we need in order for V to be an open set. Okay, so that was for Rn. And we'll also prove the same thing. Call it a lemma again. Same thing, but just for the sphere. Yeah, so and then you've got the open subset of the sphere, and V is a path component of U. Then again, then V, I'm going to claim, is also open. And the proof is more or less the same. So if A is in V, then we can choose some epsilon greater than 0, where this open ball sort of regarded as this kind of open ball, I mean sort of within Rn plus 1 effectively, but we're taking that intersection of that with Sn is going to be contained within U. So this is and we can assume that epsilon's less than 2. Right? If epsilon, just make epsilon epsilon extra small if we wanted to, so might as well assume it's less than 2. Now, if I've got some B lying in this open ball, then we've got a path T is to 1 minus TA plus TB, right? So now, of course, this is in Rn plus 1, but it doesn't lie in the sphere, but I can divide by its norm. And so this is going to be, there's a path in this open ball A epsilon, which is contained in U. Joining A and B, and so as before, and then this kind of works. So, what was the point about epsilon being less than 2? I mean, this is okay as epsilon less than 2. That ensures that B is not equal to minus A. And therefore the straight line from A to B doesn't pass through 0, and so this denominator here is not 0. We're not dividing by 0 here. And so we've got this path here, and then the rest of the proof is just the same as for the Rn case. That means that all of these B's they must lie in the same path component as A. In other words, they lie within V. We've got this whole ball is contained within V, and that proves that our V is open.